Welcome to a new video on my home automation OpenHAB and Node-RED series. Do you remember this guy? I got this from ICStation.com and I did a review video on this a couple of weeks ago. So this is an LCTech Relay X2 board from LC Technologies. And in that video I was talking about how it works out of the box with the firmware which is supplied with this unit. And it was nice, but it's not really up to, well, I guess my sort of standards where you want to control stuff with MQTT or over HTTP. And one of the first comments on the video was that actually somebody made the ESP Easy firmware to work on these units, in which the ESP01 is controlling an MCU, which is STM MCU down there, and is doing all the job of controlling the relays. And after a couple of weeks of trying different firmwares and talking to people on the forum, I actually managed to make it work. So this video is about how you can turn the stock firmware on this and make it work with ESP Easy and then control it via MQTT or HTTP. I just want to highlight because even on the forum, the ESP Easy forum, it was said that there are many different variants of this relay exist and there are different clones and some of them are much worse than the original one. So my one is this one. So it says ESP8266 Relay X2 LC Technology www.lctech.cc, and the front looks like this, and of course the ESP comes off like that. So let's dive in and see how to make this work. First of all, I would like to say thanks to all the guys in the ESP Easy forum because they have done all the hard work and they also helped me to get this unit actually working. It wasn't that easy, but it wasn't that difficult either. I mean, I just had to try a few different methods, but after all, it is really easy. It only takes a couple of settings. If you want to read the whole story, in the ESP Easy forum there is a serial MCU controlled relay/switch topic, and in that, if you go to page 14, I have posted all the details here, so you can see this post 138 where I put the pictures of, again, the unit, just to make sure that you have the same unit, and the settings in ESP Easy. The firmware that I used is this particular one. It's ESP Easy 1 MB 258K spiff puya.bin, and you can find this on page 12, post 120 of this thread. So if I scroll up and I go to page 12, I think it's somewhere towards the bottom of the screen. So that's the zip that you need to download. Once you have downloaded the zip, you need to extract it and you will get the bin file that I said in the post. And you also need esptool.exe. Again, I have a link to that in the video description, and you need to issue the following command. So esptool/vv/cd nodemcu/cb 115200/cpcom5. Of course, you need to change the COM port to whatever COM port your programmer gets assigned to, and then the rest CA 0x and what is it, 5 zeros I think, and then -cf and the bin file name. So you do that, and then it's going to burn the firmware into the ESP01. I'm not going to show the steps of how to burn the firmware because I've done this enough in many of my videos. I also want to reference to one of my earlier videos that I have done on an ESP01 programmer, but I've also bought this separate one off eBay. So I like this programmer because it has a small switch here which allows you to switch between programming and UART mode. And then, by the way, it has markings like this. So it says Open Smart USB to ESP01 adapter, and it's red, and it looks like that. So again, it's quite easy to see the find it on the listing because it does have that switch. So that position of the switch is programming. So you put the switch in to the programming mode. You put the ESP01 like this, and then you plug it into your USB, and you can issue the esptool.exe command to burn the firmware, and that's it. And once you have done with the programming, you can switch it back to UART mode, plug it back into your PC, and you can start configuring ESP Easy. Of course, you don't really need that. You can plug it back straight into the board. And then, by the way, this is how the board works at the moment. So I have a 12-volt power supply connected, and as you can see, you have the red LED on the ESP01. You also have a red LED here, and you have a flashing green LED. And If you remember the previous video, these two buttons switch the access point mode back to the normal operating mode. None of these buttons are required anymore. You don't need to press any of them. There is no further configurations required on the board. All the configuration is going to be done in ESP Easy in the software. Of course, once you have flashed the firmware, you need to do the initial configuration of the ESP Easy. Again, I'm not going to go through that. I've covered it in previous videos. So the ESP is going to create its own wireless network. It's going to be called ESP_0. You connect to that wireless network by typing the password config ESP. Once that is done, you are connected to the network. You just go 192.168.4.1 and you configure your wireless network. So you just select the wireless network from your wireless network from the list and then type the password. And once that is complete, it should connect to your wireless network and you can do the configuration as you can see it here. Of course, I have done that. First thing I want to do is I want to go to config. So the first thing which is important here is the unit name, because that will be used in the MQTT messages. So I just left it as LCTech. And of course you have all your other settings here. The next we need to go to the controller, and that's optional. I've done this because I wanted this to work for MQTT, so obviously I needed to set up my MQTT connections here. So in the first one I picked OpenHub MQTT. You can use other MQTTs as well. I just like the way it is automatically creating this controller topic and the subscribe topic and the publish topic. So the configuration is really simple. Again, you need to provide your MQTT broker's IP, port, user ID, and then password. And of course, you can leave the subscribe and the publish like this. So it's going to pick the sys name, which is the unit name that we had just configured. So that will be LCTech here for me. And that's the reason I'm going to use the /LCTech/ for most of the messages. I haven't made any changes on the hardware, but I needed to create some devices. So the first thing, which is specific and really important for this particular machine, is to create a device which is called serial MCU control switch. So you create a new device, you select the device as serial MCU control switch. You provide a name, which is not really necessary here, so I just called it relay. I ticked that enabled. From the switch type, I picked LCTech. Number of relays, well, this particular model has 2 relays. The serial speed needs to be 115/200. And that's it. And I left the relay names like relay 0, 1, and 2. Ignore the fact that it shows 3 relays, but in fact we only have just 2 physical relays. I created 2 more devices, and these are just standard stuff that I usually do, so I can see that the MQTT messages are being sent correctly by the client. So basically what it does, I've created a device which sends the Wi-Fi signal, so we can just look into it. So the device is a generic system info, the name is Wi-Fi, the indicator is Wi-Fi RSSI and 60. So it will send the Wi-Fi signal strength every minute. And the third device is going to send the uptime again every minute. And that's pretty much it. I enabled the rules. I'm not using the rules at the moment. Notifications, I haven't made any changes, and well, tools is just tools. So we are not using that at the moment. So that's all which is required to get this relay configured in ESP Easy. I'm going to use Node-RED just to show you how you can control it using MQTT and also via HTTP. So let's first do the MQTT. We are going to control it using commands, and for that you need to send the messages into the command topic, which is by default is / the device name. Again, just to remember, so the device name, the config is here, the unit name, and then /cmd. So in my case, it's /LCTech/cmd. So that's what I've configured here in the topic. I just left all the other settings as default. And we can basically send 4 different messages to turn the relay 0 on and off and turn relay 1 on and off. And the messages are really, really simple. So what I have done is these are just simple inject nodes which send in a timestamp. And here I am setting the actual payload. So that's the payload that you need to send to the MQTT topic, which is again really simple. It's basically says relay, comma, and the first number is 0 for the first relay and 1 for the second relay, and after a comma the second number is 0 for off and then 1 for on. So to turn off the first relay, or the relay number 0, it's relay, comma 0, comma 0. To turn it on, it's relay, comma 0, comma 1. And to turn off the second relay is relay, comma 1, comma 0, and the second one, turning it on is relay, comma 1, comma 1. Yeah. So as you can see, I've turned the first one on, I've turned the second one on, I can turn the second one off and the first one off. And I've also done a very simple UI for this one. So here we have just a simple switch which is sending out 1 on and then a 0 on off. And in here in this change node, I'm just using a really simple JSON expression to say relay, comma 0, comma, and then I just add on the payload. So I get the message in the same format what we have seen before. And with this, we can easily control the relays like that. And it is working really, really easy. And I just want to show you also that I have subscribed to all the LCTech topic here. So whenever we are making changes to the relay status, then we will be getting a message back. So I've just, let me switch off the relay 0. Oops, sorry. Too many presses. So I'm getting a message on topic /LCTech/relay/relay 0, and the payload is either 1 if the relay is on or 0 if the relay is off. So the way the status is working is that the ESP is sending the commands to the microcontroller to turn the relay off and on or off, but there is no actual confirmation coming back from the microcontroller. I mean, that's how the microcontroller is programmed. It's not something that is not done in ESP Easy. So ESP Easy always assumes that it can send the message is received by the microcontroller, and the microcontroller is able to switch the relay, which it should do, I would say probably 100% of the time. But the message that you are getting here, the status message, is not the actual physical status of the relay, but I think we should treat it that it is. And by the way, we can see that the Wi-Fi and the uptime messages are again getting sent every minute. So that's the MQTT part of it. It's really simple. If you don't like MQTT, you want to control it via HTTP, you can certainly do that, because the same commands, the relay /0/0 commands, also work via via HTTP. And the way to control it is you send a HTTP request to HTTP / the IP of your ESP, and then /control $CMD equals, and you send the same commands what you have sent as a payload in the MQTT. So it's either relay, comma, the ID of the relay, which is either 0 or 1, and then comma, the state of the relay, which is 0 for off and 1 for on. So you can see that's how the relay 0 off looks like, and the relay 1 on, relay 0 on looks like, and relay 2 off, and relay 2 on. And of course I have done the same for the UI. So you have a switch which is sending 1 or 0, and in here I just append that to the URL. And if we test, what's the current state? They are on. Oh, okay. Sorry, my bad. Because I did this flow a couple of days ago, and for some reason the IP of the relay has just changed. So the current IP is 148. Yeah, so I need to change for all of them. So I just changed the settings, and now I can control via HTTP as well. So it is all working. So if you are planning to use this device via HTTP, then it's a good idea to use a fixed IP address so you don't run into problems that I just ran into a couple of minutes ago. And by the way, if you didn't know, in the ESP Easy config, so in the config tab here, you can set the fixed IP. So you put the fixed IP here and the gateway and the subnet and the DNS. And of course, leave them empty if you want the HTTP. And as you probably noticed, even though I'm changing the relay states via HTTP messages, the MQTT response, which is sending back the status, still works. And of course, it works via the UI as well, or the dashboard as well. So I can change the state of the relays. Oh, and by the way, I just made a mess in the code because here in these last two boxes, I was supposed to change the message.url and not the message.payload. So, but the code that I'm publishing, and by the way, you can find the link to this code in the video description, is going to be correct now. So that's all there is to it. When I got this relay and when I did the initial review and I realized that it only responds to TCP comments, I thought it's going to be quite useless. But once I found out that I can use ESP Easy and I can control it with MQTT, I think it's going to be quite a handy device. And it wasn't that expensive as far as I can remember. Of course, I got it for free because it was like a review sample. I hope you find this video useful, and if you have the same type of relay, then you will be able to get it working with ESP Easy. And by the way, if you have any issues, I would suggest that you go back to the forum that I was talking about in the beginning of the video, because those guys have a lot more experience than I do. Thanks for watching, and hopefully see you in my next video.